All right. So our goal was to really help the guys that usually help us, so the service desk agents within the company of Julius Baer. And basically what we wanted to do is provide them a feature with which they can automatically classify the tickets that they receive and that they also create. So what we want to do is 3 predictions. First, we want to know, just based on the customer inquiry, which application, service, process is affected within the company. Second, we want to know, is it a request or incident? And third, which support group can really resolve the issue. So, I mean, if the service desks cannot resolve it on their own, they need to route it somewhere inside or outside of the organization. Julius Baer as a company has quite grown in the past 2 decades. So we have 3 central service desks, one in Montevideo for LATAM, one in Zurich for EMEA, and Singapore is responsible for APAC. There are a few exceptions, like smaller service desks that just cater their local branch office, for instance. But first of all, they all use the same ticketing system, so they all have the same data model that they access. And second, they need to help each other out. So we have a certain model of follow around the sun. So these people have to know about the specifics that are applicable in their country or city. And of course, one of the biggest challenges within service desks is that they cannot resolve all tickets on their own, so they need to route tickets. And this requires a lot of experience from the agents and sometimes also obviously research. And this can lead to downtime delays and something that we refer to as ping pong ticket. So a ping pong ticket is when a ticket goes back and forth between support units. And service desks are usually the main competitors in these rallies, because they receive the ticket first, they hear the complaints or whatever is wrong first in the chain. So what we try to solve is really this handshake between first and second level support. And I guess sometimes the expectations are a bit that if you scream loud enough into the organization, then someone will pick up the incident. But in reality, it's a large organization. Everyone's busy, everyone's working hard, solving problems. So that's exactly where we want to give people the opportunity. So they're not in that role where they have an incident and they do not know where it belongs to. And with the press of a button, then with the feature that we provide them, they get a prediction where they could put the incident to in the organization. So we've been talking a lot about tickets. Tickets have mainly 2 parts that are interesting to us. So the header contains a lot of system generated data, so like ID, timestamp, who opened it, and so on. But the main part that we really want to look at in this case here is the description. So this is really what the service desk agents type into the system when they are in contact with the client or they get submitted via mail. So we'll see in a second. The vocabulary is very domain specific. So there are a lot of abbreviations in there, a lot of project codes that are just customary to Julius Baer. So it's like a Julius Baer language that we see here, basically. We have a mix of languages, even though our corporate language is English in Julius Baer. Some clients still write in their main language. Also, service desk agents sometimes submit or include quotes from the customer directly just to really capture the meaning. Obviously, there are many spelling errors because the service desk agents, they have to listen, they have to type, they have to provide some guidance at the same time. And length is mostly short and concise, so we're about 30 to 40 words on average. So the first thing we want to predict really is the affected service and application. We have more than 800 classes here, so quite a lot. And that is really important. So that prediction, I think, is the most important one because first of all, we want to do reporting on that because it's a very good indicator where problems are within the organization. And second, it allows initial routing because as soon as you know which application or service or process is the one that is affected, you know that there's a default group behind it, so you can route it in that direction. Then we want to decide whether it's an incident or request. Of course, we never want to misclassify a request as an incident because incidents, they can affect people at night. So if there's an emergency standby team and you have an incident, there can be text messages sent out at night or even possibly calls dispatched from the emergency standby team. And of course, the last one, we will know which team, so which support group, which group of warm bodies in the company can really resolve this issue. So this does not have to be the full team of this application. This could also be like a platform team, like a DBAs or the middleware guys. So here we see a few examples. So first, you can see the blue X icon in ASU doesn't appear, or the username and password and so on. You clearly see these are full of like abbreviations that are just really customary to Julius Baer. Second one as well. And the third one is one we see very often. So the user just describes what happens on his screen. So there's no keywords, no like thing that you could search for in general, which application it could be. So a lot of clients, they don't refer to application names. They just describe what happened on their screen or what went wrong. So the general approach was we took all the tickets from the ticketing system, we did a lot of pre-processing on them, and we ended up with about 500,000 incident and interaction tickets in our training set. It's about 250,000 in our test set. And basically on past assignments, on past routings that have been done by the organization as a whole, not only the service desks, we trained a neural network. And basically that trained neural network then predicts to you where you can route tickets in the future. So how do we get the right model into production? First of all, one thing that we found out is really involving the customer paid out. So really giving the models as soon as possible, as soon as you have some good numbers in accuracy and macro score, giving the models out to the service desks was really good to see how they use it, and also the feedback that we got was incredibly valuable. We could not have made it without the feedback that we got from those guys. So every now and then, when we incorporated the feedback in those models and when we made progress ourselves, we deployed it again. So we continuously deployed and held feedback sessions with the service desk over the course of the last year. Then we also obviously monitored the results ourselves. We looked at, most importantly, if they use it at all. So obviously we saw on our API how many calls they make. And we also checked that thing that I described, these ping pong tickets. Do we see a decrease in those, or how does it behave based on tickets that those agents that have the model, basically how they deal with that? And of course, it's we're dealing with neural networks, so you have to try a lot of things. So we tried a lot of different pre-processing techniques and a lot of different architectures, but I think I can show you this here. So every model has been benchmarked with the same data at the end. So the same pre-processing pipeline. As you can see here, the logistic regression was already quite good. There's a difference in test accuracy and macro of one score because we have unbalanced classes. So we still, after pre-processing, are left with about 320 classes. And we still see difference here because the macro font score weights every class the same way. Interesting to see that with just neural networks, with plain neural networks, we don't get much better results. However, when we start to capture the meaning in an embedding layer, to capture the meanings of the word, we get to better test accuracy. And when we start using more specific neural networks like CNNs, LSTMs, GRUs, we get better results. Best results were achieved with CNNs. And obviously, if you've been following like the trends in NLP in the past few years, I mean, there's no way around getting this guy, so BERT from Google. The original model, we tried that, we fine-tuned it towards our task, but the results were not better. Rather, they're a bit worse than our own word embeddings. And then we tried different variants of BERT, so like Electra, for instance. But the one that performed best was the one from Facebook, so Roberta, but still worse than our own CNN. However, we found out that you have to really look at the language model, and the language model lacks all those domain-specific words. So when you start further pre-training those language models, those large models by Roberta or also BERT, you get much, much better results. So we got up to 93% test accuracy and 0.81 macro font score for finding the proper service or application just based on the initial inquiry from the customer. So you might argue now 0.05 in macro font score is not a huge difference, but it was really there for the service desks to be able to notice that there's a difference, because as you can see, 320 classes, so it can make a difference, and that they were able to say that, for instance, the Roberta model is better for their use than the CNN. So how did things change? We got the feedback in last October that we could go live with the models we have from the service desks, from all the service desks. They were really happy with the solutions we provided. So we integrated it into our ticketing system. So now they can just, with the press of a button, basically get the prediction where the ticket belongs to. So route the tickets really automatically. And in March, we went live with support group prediction. That's a bit more sophisticated feature. So they get predictions where the ticket could belong to. And since then, we see frequent reusage. So we see a few hundred API calls from the service desk guys to get the predictions. And it seems most useful to new joiners in the service desks because they don't know the organization yet that well. Service desk supervisors, those are the guys that are really familiar already with the company. They use it a little bit less, but they use the support group prediction more. And really one feedback that I found really, really cool was that they told me, like in a feedback session, that the model really behaves like they would. So after all these pre-processings that we changed, after all the changes we made to the models, the improvements, they said really the model just routes ticket as they would. And they're really impressed by that. And in general, they really like it because they have much less work in terms of ticket quality management. Whereas before, they had to do a lot of manual work looking through the tickets if they've been routed correctly. And obviously, we also looked closer at changes in ticketing data. So how do these past assignments change? So we saw distribution that was very unbalanced. So a lot of classes, we call these bucket classes, they got a lot of tickets in the past. And these bucket classes now tend to get less tickets than before, which is something that's really cool. Also, we see a decrease in those ping-pong tickets that I referred to. So we see less reassignments in general of tickets. It's hard to judge by the numbers. Since we started to introduce and to go live, it's about 15% safely assessed, maybe a little bit more, but I can assure that it's about 15%. And if you look at a few thousand tickets a month, that is a lot of time you give back to the organization. Also interesting, some support groups tend to get more tickets. So some L3 groups get more tickets than before, not in all classes, but in some. And we are investigating that, obviously. There we see that sometimes the knowledge management or the knowledge transfer between L2 and L3 is not where it should be. So the model decides that this group is more successful, so I give it possibly to this group because they got a better closure rate at tickets. So to summarize, I think this feedback loop of having really a client behind the system and evaluating it ongoingly, that you can really communicate with the client also was fantastic for this kind of project. Pre-processing, I mean, I showed you the improvement that we made with the different models. Yes, that was important to try different models, but the pre-processing, to change the pre-processing pipeline, I think made the bigger difference after all. So again, understanding the data is core to everything. The language models, they're really nice from BERT, Google, Electra, and so on, but you need to pre-train them if you're in a domain-specific area. And so thus I can summarize, text classification works really very well for routing tickets within a large organization. So thank you very much for your attention. And I'm more happy to answer your questions right now. If you have further questions after that, you can also send me emails. Thank you.
Thank you, Michael, for this very nice presentation. I think we have already 2 questions in the chat. I have also a question myself. Maybe we start with the questions in the chat. If you don't know if you can see them. First one from Joel Niklaus, I think. How does the label distribution look like, and how did you combat label imbalance?
Yeah, so the label distribution was like the top 10 classes, as I remember correctly, made up about 70% of the total tickets, I think. So just 10 classes that made up the whole volume, whole of the volume of the tickets. And one class was especially strong, was the one that is responsible for everything that is related to your workplace. Obviously, a lot of tickets just get tossed in there. How we handled that was we set weights in the training. So you can set weights. We experimented with using different weights for the different classes. And so it's like a penalty for certain classes that they get less weight than others. That's how we dealt with that situation of unbalanced classes. And this worked quite well for us.
All right, I hope that answered the question. If Joel has a follow-up or is satisfied?
Yeah.
Yes. Okay.
Yeah, if I may. So, you did it anti-proportionally to the label occurrence in that case. Okay.
Yes.
Great. Thank you.
All right, thanks. Then we have a question from Leandro in the chat. And if there is any other question, please write them in the chat or raise your hand. So the question from Leandro is, what does the distribution of the remaining 300 classes look like? The macro scores look really impressive for that amount of classes. So how does the distribution of the remaining classes?
Yeah, so we started with more than 800 classes, then in the pre-processing we got down to 320 classes. I think those are the classes that you refer to, Leandro. So the ones we really had then in our ticket set, right? So the distribution of those looked about the same as before, pretty much. So there's still the top 10 that really made up about 70% of all the tickets. However, you can see a lot of very specific terminology in there. So I think that's why the benchmarks were that good in the end. So that's why the macrophone score was that good. There are a lot of very term-specific things in there. And if you get to the more generic classes, the descriptions get a bit more vague in general. That's why it worked that well, I guess.
Right, thanks. If Leandro has okay, he says thanks. Now, the next question on the chat by Summer is, how does the language distribution look like? And how do you deal with multiple languages?
Yeah, it's really interesting. At the beginning, we started using LangDetect and other frameworks to detect the languages of the tickets. But as there are more languages, or can be more languages, even within one ticket, at some point we just said it does not matter at all. We tried to take all like English tickets and toss away all the rest, like German, French, Spanish, Portuguese tickets that I saw in there. That was about, I guess, 20 to 30% of the tickets. So yeah, so 70% of the tickets or 80%, somewhere there, I don't remember the numbers properly, were about English tickets. So only a small fraction, not a small fraction, but a smaller amount were in another language than English. But in general, we got better results when we used just all languages together in a pot. So when we did not separate with just English tickets, we did not get any better results than when we just trained the model with all the languages in general.
Because you used a multilingual language model, I assume.
No, we did not. That was interesting. We did not. No, not at all.
Okay.
So you used an English language model on all languages, and you were better than using.
Yeah.
That's very interesting.
Yeah, I thought so as well.
There might be some correlation between language and topics.
Exactly. That's what I assume. That's what I just wanted to say. That's exactly that. There
or
like
some words in specific languages which might be correlated to specific topics.
Yep.
That's my assumption, of course. Well, thanks. This is really interesting. If there is anyone else who wants to ask a question in the chat, I think we still have a bit of time. I have a question myself, and this is a sort of meta question. And having worked with banks myself, I'm a bit surprised that you managed to present this work at all, because my impression is that it's not that easy to convince them that that it's a good thing to advertise their internal activities. Was there any kind of similar problem for you? Or it was all fine from the beginning and all accepted that you would publish and present?
So I had to leave out a lot of numbers here that I would have loved to tell you or to show you. So like the distributions, for instance, also the number of tickets that get generated on a daily basis, how many reassignments are there. So all those things, unfortunately, I had to cut out of the presentation. So to give you really the numbers, I would have loved to show you also distributions, but that's exactly what you refer to, right? That these things,
yes.
Unfortunately, I could not show. So yes, there was a bit of censoring in regards to what I could show here.
Still, you could give us the gist of your work, which was very interesting. And related to that, I had a question. Of course, there was any private information. I mean, actually, now in the presentation, of course, you had to omit everything that they told you to omit. But during your work, there might have been some kind of privacy-related information, identity revealing information in the tickets and set. Might have been talking about a specific client, providing name or something. And how did you deal with them? Did they provide anonymized version of this for you, or there was some kind of agreement that allowed you to cope with the situations, or did the problem never appear?
So there's a lot of information in these tickets. You're absolutely right. There are client names in there, there are account numbers in there, there's even amounts in there of transfers of money sometimes. Yeah. So how do we get rid of that? Well, first of all, I'm the owner of the system, so that's a bit of a benefit because then you can really use it. But of course, we have some patterns for account numbers, which we got rid of. And obviously also we got rid of any names in there because that's also what we don't want in the data, right? So we did some entity recognition during the process to get rid of that data. So we just have the description in there of what really the problem is.
Well, my question is specifically related to the fact that this is, if I understand correctly, is collaboration between the bank and an academic group. So I was wondering whether this was smoothless or this kind of problems had to be solved in advance.
So everything was done on premise. That's one of the backdraws that we had. Also, I saw this question that someone asked: did you use Excel and Roberta? Unfortunately, no, because we did our hardware wasn't strong enough to use that model because it's a huge model. So we had to do everything on-prem. That was one of the backdraws, and the work I did together with Don and with Mark, with everything was anonymized. So I had to make sure that there's no leakage of data in any way.
Okay, so I think we are. If there are no further questions, we might be ready to switch to the next presentation, which is due to start in a couple of minutes. So thanks a lot, Michael, for the presentation. Very interesting. And now we ask the next presenters to prepare.